Or some student might think that, wow, I like chemical, I like the lab, I like to do research, whatever. So how about today? We have invited Dr. Bear Jin Jun, and he is the assistant manager from the R&D department of Top Glove International Sdn Bhd. So now today, let's invite Dr. Bear to share with us his job scope in Top Glove. Thank you.
Good morning to Dr. To, my respected industrial counterparts, and also fellow audience for the day. Firstly, special thanks to UTA Department of Petrochemical Engineering for inviting me to this forum. It's my honor to share what chemical engineering is all about in this glove industry. Before that, let me introduce myself. I'm Dr. Bay, PhD graduate in chemical engineering from USM, and currently I work as assistant manager in Top Glove R&D Center. So here is a little bit about myself. I started my Top Glove journey in 2019 as a researcher, where I was assigned to pioneer synthetic latex research and work on glove defect troubleshooting project. And 2 years later, I became a senior researcher to lead the synthetic latex research team in glove development and also lead the factory quality improvement task force. And driven by my achievement, I was then promoted to assistant manager and now currently leading the R&D Tom Glove task force and also working on the second grade glove and glove weight improvement. So far, my career achievement has culminated in the prestigious Top Glove Group Best Staff Award in financial year 2022. Now let me begin. What is glove industry? As we all know, glove is a piece of garment providing protection and comfort against hazards for our hands. Over the past decades, glove industry has actually evolved with many types of glove in the market now. For example, natural rubber glove, nitrile glove, surgical glove, and household glove. So despite the wide variety of gloves, glove manufacturing process is essentially similar, which is this. Looks complicated, right? But no worry, because today is actually not about a lecture on glove manufacturing. Instead, I shall make it simple and focus on what chemical engineer can actually contribute to this industry. In layman terms, glove manufacturing consists of two major processes. The first one is the process chemical preparation, and the remaining one is the glove production, which itself consists of three further sub-steps: formal cleaning, coagulant and latex dipping, and post-processing and packaging. So I will provide a brief explanation on each of these, followed by the role of chemical engineer in them. So let's begin with process chemical preparation. Glove production actually requires many chemicals: acid, alkaline, coagulant, latex, just to name a few. All these actually need to be prepared accurately for the use of production. So chemical preparation generally involves chemical weighing, followed by pumping to the tank for stirring and mixing. And after a certain duration, the chemicals are considered mature and ready for supply to production line. So what chemical engineer can actually do here? First is to ensure the weighing accuracy, which includes preparing a raw material by following proper dilution, weighing according to the formulation dosage, and calibrating the weighing machine. And next is process monitoring and control. Throughout process chemical preparation, many parameters will need to be controlled well, such as chemical pH and concentration, process stirring speed, tank cleanliness, and chemical condition. This ensures that the chemicals used remain stable without contamination. And lastly, an engineer can never escape from process improvement. It can be in terms of process design, efficiency, or cost. For example, improvising piping configuration and optimizing the stirring speed for energy saving. All these are actually closely related to chemical engineering, as knowledge of fluid flow and transfer will be required. Now, let's go to glove production. As described earlier, it starts with a formal cleaning process. For your info, former is the hand-shaped mold used to produce the glove. The clean formers then proceed to dipping process, where a thin coagulant layer is coated onto the former surface and dried, followed by coating of a thin latex layer that reacts with coagulant to form a wet film. The wet film then undergoes post-processing, such as excess chemical leaching, high-temperature curing, and dawning improvements such as chlorination, before being stripped from the former as glove for packing purpose. So, how about the role of chemical engineer here? Similar to process chemical preparation, it is important to check the quality of incoming chemicals, as not everything from upstream may be perfect. This includes checking of chemical concentration, pH, and condition, such as sludge formation, which indicates chemical destabilization and may eventually lead to poor glove quality. A production engineer also covers process monitoring and control. As the process here is very much different from the process chemical preparation, different parameters will need to be controlled. For example, tank temperature and level, oven temperature and cleanliness, and brush positioning for formal cleaning. And lastly, a production engineer is involved in production process improvement, be it design, efficiency, or cost. For example, study to reduce oven heat loss to improve oven efficiency and reduce utility costs. Again, this is closely related to chemical engineering, as it involves knowledge of heat transfer. Now, no matter how well you control the process at your production, sometimes you might still face glove defects, such as tearing, pinhole, pin area, etc. And this is where chemical engineer can contribute in the area of research and development, namely troubleshooting. While there is no precise formula for troubleshooting, primarily it involves three aspects. The first one is to analyze the process, first to identify line abnormalities, and also whether any non-compliance in process parameters. And then we'll try to correlate them together with the glove quality data to identify root cause for the defect. However, sometimes the issue is more underlying than just a simple process analysis. In this case, in-depth analysis on the affected glove will be required, like evaluating the physical properties, chemical composition, chemical bonding, and color for the glove, and to benchmark it with a good glove to identify root cause. From here, if the glove defect is deduced to be caused by the production chemical, we may then conduct further analysis on the suspected chemical. For example, evaluating particle size, pH, viscosity, and surface tension may reveal potential problem of the chemical such as stability and pickup ability during the dipping process. Here, the knowledge that can be linked to chemical engineer shall be analytical chemistry and also particle technology. So here are some examples of the equipment that are commonly used in glove industry. We shall not go into the details of each of them, but generally the top row over here is used for glove testing, while the bottom row is actually used for chemical analysis. And as the glove industry evolves, there might also be new or changing customer needs, interest in new or improved feature, more market competition, or revised regulatory and sustainability compliance requirements. All these drive the need of new product development, which is another area for R&D to contribute as a chemical engineer. Here are some examples of new glove products that has been developed in the past decade. As the name suggests, all of them carry special features in addition to basic hand protection, which make them stand out in the market. So, generally, the scope of new product development can be simplified into three areas. First is R&D study on suitable chemical formulation and process parameters to produce the glove. And with every adjustment, we need to evaluate the glove properties such as dimension and physical properties, and whether they fulfill international standards such as EN, ASTM, and ISO standards. There are many international standards as they apply to different regions of the world. And from there onwards, we may further evaluate the occurrence of the glove defect, and most importantly, its special feature, which is the starting point for the whole new product development. Here, knowledge on polymer chemistry is essential for chemical engineer, as it will help a lot in decision making for any chemical formulation and process parameters adjustment during the R&D study. So, how about the flow for this new glove product development? A glove product development typically begins with lab work, where it can be produced under well-controlled process to provide reliable benchmark for upscale. And once the results are acceptable, trial run stage comes, where the chemical formulation and process parameters that have been optimized in the lab are tested in the actual production line, in which the condition is usually less ideal compared to inside the lab. For example, in the line, the equipment usually has more wear and tear, and the oven has more heat loss. So here, fine-tuning of chemical formulation and process parameters are usually required to achieve satisfactory glove properties and quality. And once fine-tuning is completed, the trial run results can now be analyzed to establish the product specifications and identify the glove selling point to the market. And finally, a new product can be launched, actively produced, marketed, and promoted to the world. Alright, so before we end, let's recap again on glove industry. Glove, as a single-use consumable item, is a dynamic and growing industry with a steadily increasing demand. Hence, it offers plenty of interesting opportunities to chemical engineers, such as process monitoring and control, process improvement, glove quality troubleshooting, and new product development. In fact, with this growing industry, more surprise might even await us in the future. So, we sincerely welcome all of you to glove industry.
Wow.
So, yeah, thank you.
Thank you. Thank you, Dr. Bae, for your sharing. So from your sharing, we found that, wow, it's quite interesting because you have you play the role to develop a new product rather than beside you need to work in improve the operation part or do some analysis part. So this is another different job scope that we never imagined before. Yeah. So I would like to ask you, as we know that Atograph is an international company and they have many branches all around the world. So may I know, do you have any opportunity to travel to the other branches in overseas?
So thank you for the question. So because now I will try to answer this from two perspectives. One is from the R&D perspective, another from the factory production perspective. So because I'm from R&D center, so from R&D perspective, we actually serve as some sort like a headquarter where we coordinate certain studies across different factories. So in this regard, we R&D people will definitely have a lot of chances to go to different factories because currently the way we work is, for example, we are improving for a certain aspect. Let's say we are an energy saving team, or for example, we are a troubleshooting team. So whenever we go to a factory and we learn something interesting or new from a factory, the role that we play is actually we will facilitate the information transfer between factory to another factory. So because we have a lot of factories, so definitely info sharing is the best way to improve all factories together for the good of the whole company group. And if from a factory perspective, because when an engineer is assigned to a particular factory, definitely you only work in that factory, but not in other factories. But as we all encourage learning in the company, so what the factory can do is actually sometimes we can always arrange interesting technical exchange session because usually people from the same department but under different factories, they know each other. So this is another channel for the factory people to actually facilitate those knowledge transfer without actually requiring the help of the headquarter department such as R&D. So as long as the factory people is willing to take initiative to initiate technical exchange session. So actually they also get to know what's happening around in other factories. So in short, I think no matter what is the role, as long as we are willing to put in effort, put in the hands-on effort to go to different factories to learn new things, actually there's no limitation as to how we want to work in, we can get exposed to all these different factories with different designs.
Okay, understand. Wow, means that even within the branches, you also can have the opportunity to learn with each other. Yeah. So such a very interesting part that you have shared with us about beside and chemical engineer can involve in the processing, the production part. We still can have the chance to work in the laboratory to carry out a lot of analysis thing and also do the product development. All right, thank you for your sharing today.